Hello and welcome to another episode of Study Session for AP Calculus BC. In this video we will be covering implicit differentiation, which is essentially how you would derive something like the equation for a circle, where you would have like x squared plus y squared equals, let's just say, like 25, whatever. If we want to derive this, sure, we could minus x squared and take the square root of it and have plus or minus the square root of this, but it would be quite a pain to derive. So that would be using explicit differentiation, but now we're going to use implicit differentiation. So let me quickly go ahead and erase this stuff. So basically, with implicit differentiation, it's based off the whole concept of what you do whenever you derive. So if we had y equals 3x plus 5, or whatnot, so we take the derivative of y and we get dy over dx equals, and we would typically just say 3, but it's really 3 dx, but because dx over dx is 1, then you don't write that down, so it's just dy dx equals 3, okay? So we take that same kind of concept where the derivative of y is dy dx, the derivative of y with respect to x, and then we apply that to different functions, and more not functions, because functions you'd use explicit differentiation, different equations, to where you can derive now. So let's start with an example. Okay, so if we have x cubed minus y cubed, and we have that all equal to y, and we want to know what's the value of dy dx, what's the derivative of this function, derivative of y with respect to x for this function. So first we'd go to derive. Okay, so we'd get 3x squared, and then remember dx, so, but I know that's going to be 1, so I just won't write it, minus 3y squared dy dx equals dy dx. Okay, so here we have dy dx in two terms, so we have to get them all on the same side and then factor them out. So we get 3x squared equals dy dx, and then I'm doing multiple steps here, so I add this to the other side, and then I pull out the dy dx. Okay, so 1 plus 3y squared. Okay, so if you look at that, I added the 3y squared over there, and I pull out the dy dx. I factored that out. Okay, and to just get the dy dx by itself, we just divide by 1 plus 3y squared. So we end up with 3x squared over 1 plus 3y squared equals dy dx. Okay, and then that would be your final answer. The one problem with implicit differentiation, in my personal opinion, is that it tends to get a bit messy. So this was actually a relatively clean example, but it can get pretty nasty pretty quick. And a lot of times, how we had I'll just go ahead and quickly rewrite that. How we had 3y squared in our original equation was like x cubed minus y cubed equals y. A lot of times you'll have like x squared plus y squared equaling something or whatever, and then you have to resubstitute it into the equation, but fortunately for that one, we did not have to. Okay, so now on to the next example. So we want to find the value of dy dx at the point 2, 1, so 2, 1. Okay, and it's the equation x plus y over x minus y equals 3. Okay, so x plus y over x minus y equals 3. All right, so let's go ahead and get deriving. Okay, so we take the derivative of each side of the equation separately. So let's start with this. Okay, and we notice that we've got a term on top of another term, so we can either A, use a quotient rule, or B, say that this is like the power of -1 and use a chain rule. I'm personally just going to use the quotient rule just because that's what most people will be doing, seeing, just looking, oh, look, I got one term on top of another, I'm going to use quotient rule. Okay, so let's start with that. So we get x minus y, because that's our bottom term, times the derivative of this top term, so that's 1 plus dy dx, because the derivative of y is dy dx, minus 1 minus dy dx, because that's the derivative of this bottom term, times the top term, x plus y, all over the bottom term squared, x minus y squared. Okay, so right now I'm looking at this, and I see I'm going to get a negative y right here whenever I multiply those. So let's see if I'll be able to add or anything. So we've got 1 times y, and that's also got a negative. So we're going to end up with a negative 2y on top. So I'm going to remember that. So I'm just going to write down negative 2y. Okay, so we're going to have a positive x multiplied by that. But then we're also going to have that negative x over here because that's going to be a positive and then multiplied by that negative. So I know that x is going to cancel out, okay? And then from there, I know that since the dy dx in this term is also positive, but then this term is negative, the x times dy dx is going to add to this x times dy dx. So that's 2x dy dx, and that's a y right there. And then I look at the negative y dy dx. Okay, so that's negative y dy dx. This is going to be positive y dy dx, so that's going to completely cancel out. So this is what we're left with because we've completely FOILed that out, and that's all over x minus y squared. And you might be asking, what's that equal to? Well, the derivative of 3 is just 0, so it's just equal to 0. Okay, and so whenever we multiply this across, because we want to solve for dy dx, this will cancel out because anything times 0 is still 0. And then we add this to y and then divide by the 2x. So dy dx equals 2y over 2x, okay? These will cancel out, the 2's, so we just get dy dx equals y over x. So equals dy dx. And at the point 2, 1, this will be 1 over 2. So that's 1/2, and I'll quickly validate, and the answer is 1/2. So that's how you would perform that problem. Just gotta quickly erase. Okay. So our next problem is if we want the derivative of the equation at the point of pi over 4, pi over 4, okay? And the equation is x sine y, so x sine y plus y sine x equals pi over square root of 2, or pi equals pi over 2 square root of 2. And the good thing is I'm already noticing that this is a constant, so this is going to be equal to 0 whenever I derive it. Okay, so let's start with deriving this other side. So for each of these, we're going to have to use product rule because something's being multiplied here. So let's start with that first term. So if we take the derivative of x and then just keep y, that's just sine y, okay? And then if we take the derivative of sine y, that's dy dx cosine y, and then that's times x, okay? And then those are all added to this would be, if we took the derivative of y, dy dx sine x, and then if we multiply, if we took the derivative of sine x and multiplied it by y, that'd be y cosine x. Okay, and we have that all equaling 0 right now. So here, what we could do is we could simplify it out and stuff and actually solve for the derivative. But what I'm going to do, because I know that it will get messy and I know my values at pi fourths for sine and cosine, I'm going to go ahead and substitute in the values for pi fourths just to make my... you know what? No, I just for the sake of the video, I will actually solve for dy dx. So I'll go ahead and quickly do that. Okay, so we notice that we've got two terms with dy dx, all right? So we want to isolate those, and what we'll do is we'll minus our sine and cosine terms without them to do that. So we end up with negative, I'll just pull out that negative, sine of y plus y cosine x, and then all of that is over cosine, so x cosine y plus sine x. Okay, so now we substitute in our values for pi over 4. So we know that pi over 4 sine and cosine are both going to be equal to the square root of 2 over 2. Okay, so this turns into negative square root of 2 over 2 plus pi fourths times square root of 2 over 2. Okay, and then all of that's over pi fourths times square root of 2 over 2 plus square root of 2 over 2. If we look, these two are equivalent, okay? It doesn't matter what order they are because one of the addition properties is that, a plus b equals b plus a, okay? So we can go ahead and cancel these out. So those all cancel out, and I was just this whole term would be a 1, and you really only need 1 slash to cancel it out, but I was just doing it because more lines, it look more canceled. I don't know. But that leaves us with negative 1 over 1 equals negative 1. And that is the correct answer. Just quickly getting this erased. Okay. So, our, yeah, I'll do this one. Okay, so this is going to be our last one. And what's the second derivative of x squared? Okay, yeah, second derivative example is good. Minus 4x equals 2y minus 2 equals 2y minus 2. And it wants us to find d 2y over dx2. Okay, so we'll start by finding the first derivative. So that gives us 2, if we derive both sides, and with respect to x, we get 2x minus 4 equals 2. Dy dx. So dy dx equals 2. I'm just going to divide by 2 in my head, so that's x minus 2 equals dy dx. Okay, and if we want to take the second derivative, we derive again. So we derive with respect to x, and we get 1 equals d2y over dx squared. And our answer is 1. You know what? That was it was a quicker example than what I thought it would be. So let's go ahead and do another example with a second derivative, because there's something that has to take place that I want to show. So this one, it's take the second derivative of x squared plus 4y squared equals 1. Okay, and it wants the second derivative. Okay, so let's derive with respect to x, and we get 2x plus 8y dy dx equals 0. So we get that dy dx, and once again, I'm just doing some simplifications. I'm subtracting the 2x, and then dividing by 8y, and then the 2 and the 8, they can both be divided by 2, and that leaves 1 and 4. And since subtracting that's going to be a negative. Okay, basically, that's what I'm saying. Okay, so dy dx equals negative x over 4y. So then, if we want to find the second derivative, we derive this again. And what ends up happening is we get 4y times negative 1, because that's the derivative of negative x with respect to x, minus 4 dy dx times negative x over 4y squared. This whole term needs to be squared, not just 4y squared. Okay, so now we have a dy dx, and you might be thinking, well, what do we do? We want to solve for the second derivative, not the first derivative. Well, what you do is you substitute that in for dy dx. So let's go ahead and mentally do this math or whatever. So I know the 4's are going to cancel out, so that's just going to be negative x over y, and then multiplying this by an extra negative x, and then also this negative will give us negative x squared over y. Okay, and then this will give us, you know what, I'm just going to pull out this negative, so 4y negative over 16y squared. And then doesn't want it at a specific point. Okay, so here's where we have to think. We have to use our thinker. Okay, so this is what I was talking about earlier, where sometimes you have to substitute things in. So let's think. So earlier, we were told that x squared plus 4y squared equals 1. What would happen if we were to multiply the numerator and the denominator by y? Well, we would get y squared, this would cancel out, and then this would become y to the third. But wait, we have a value for x squared plus 4y squared, and that is, it equals positive 1. So I was just double checking real quick before I did that. So that equals positive 1. You see 4y squared plus x squared, again, that addition property, it doesn't matter what order it is, that equals positive 1. So let's go ahead and cancel this out and make it positive 1. Here we have 16y cubed, and there's no apparent substitution that we can do that for that. So our second derivative, so d2y over dx squared, it's not really x squared. I'm just kind of saying it. If I'm going to be completely honest, I don't know what to call it. Like, I know it's the second derivative, but I don't know what to call the notation. But regardless, so our further simplification is -1 over 16y cubed. And that would be the second derivative. Alright, well, hopefully you guys enjoyed this video. Hopefully it helped you. Hopefully you were able to learn how to do implicit differentiation. If you need any help, be sure to visit my website, studysession.org, and I will be more than happy to help you if I can. Other than that, if you have any suggestions, leave it in the comments below. And if you have any video suggestions, also leave that there. And that's the end of this video.